I remember basically trying to learn the technology on my own, which was not for the faint-hearted. And there were two gentlemen, Mr. McNeil and Mr. Schwendler, who were working for NASA, or one of the subsidiary companies. And they left to form their own company, the McNeil-Schwindler Corporation. So that's where the MSC comes from. And they commercialized one of the very first FEA codes. And again, a lot of it depends on the company that a young engineer might be working in. I was lucky.
Welcome to a new season of the Engineered Mind podcast, where we explore the exciting world of the digital renaissance and how it's changing the way we live and work. On this show, I will be talking to experts and thought leaders in a wide range of fields, from technology and artificial intelligence to business and education. We'll delve into the latest developments in these fields and discuss their impact on society. Join me on the journey to the future as we explore the ways in which the digital renaissance is shaping our world. In this episode, Steff Evans and I talk about MSC Apex, a CAE-specific modeling and meshing software. It offers innovative technologies for geometry preparation for FEM calculations. Steff will also talk about his experience in the FEA industry, the past, the status quo, and future of FEA, and how you can get started learning more and become the FEA specialist you always wanted to be. Support the podcast by rating it on the favorite platform of your choice to make sure more inquisitive people around the world engineer their minds. Subscribe if you haven't already. And now, ladies and gentlemen, enjoy my podcast with Steff Evans. Let's kick things off. Steff, thank you so much. Thanks for being on my show.
Good to be here, Jousef. Thank you for having me.
Awesome. Today we'll talk about FEA and Apex and what your background is a little bit, and also to set the stage, maybe give the audience kind of a 1-2 minute intro. Who is Steff? What do you work on? What are your side projects?
Yeah, okay. Thank you, Jousef. Yeah, so my name's Steff Evans. I run Evotech CAE, or Computer-Aided Engineering, in the UK. So I've a background of maybe 25 or so years in simulation across a number of different industries. So my main background is in the aerospace industry, looking at lightweight structural development. So the Airbus supply chain and the BAE system supply chain, lots of work developing military and commercial aircraft across those companies and supply chains. So about 6 years ago, I set up Evotech, FEA, advanced FEA-based consultancy. But I'm also partnered, or we're also partnered with Hexagon MSC Software for technical resales of their CAE or simulation product portfolio. And alongside that, I'm very, very active in both the development and the deployment of training in FEA technology. So I've got a number of courses that we've developed that have been taken by hundreds of people through industry, and we can talk about some of the details of that during the call. My interest in Apex came around 5 years ago, I think, when we were looking at some beta versions in one of the aerospace supply companies I was working with, and I was so impressed with the technology. It's become a sort of flagship software that we're very heavily involved with, both from a training and a technical deployment perspective into many companies in Europe and the rest of the world.
Very interesting. Okay. And we'll definitely talk about the courses, and also maybe as an announcement in this podcast on Thursday, I'll have you and Dominic actually on the show, where we will talk about nonlinear FEA. So to everyone listening to the show right now, we'll have both of the experts, so Steff and Dominic, on the show in a few days. So really looking forward to that. When we talk about FEM, the method itself, and FEA basically as the application of the finite element method, where do you see the big advantages of using MSC Apex compared to other tools that you might have used in the past?
Yeah, okay. So without this becoming a sales pitch, and speaking from my own perspective in terms of the way I help companies with my consulting work, Apex has a number of technologies which make it pretty much best in class for lots of simulation scenarios and sort of thing that people are looking at. The major benefits are based around things like direct modeling, which is a a CA-focused geometry manipulation tool, which means you can build and modify and verify the behavior of some very complex models in a time frame and a manner that you just can't do with third-party tools or legacy software that's out there in the marketplace.
Got it. I was seeing one post of you on LinkedIn, by the way. I'll go and follow Stefan on LinkedIn because he's sharing awesome stuff. Where I saw the UI and UX of Apex, and it's really, really fascinating how that looks like. Very minimalistic, yet like you find everything in one interface. How does it facilitate the work for engineers using Apex in their day-to-day work?
Okay, so yeah, the UX or the user experience through the interface has been completely redesigned from the ground up. So it gives lots of access to technology in a very easy to use and easy to learn manner. So the actual layout, I don't know if you can overlay some screen grabs or recordings over the way we're talking now, but the icon and the toolset structure is very elegant in the way that it's positioned around the screen. And also, when you're using a particular area of the functionality, that's all you'll really see on the screen at that time, alongside with the model. Another key aspect is the fact that all of the functions in the Apex environment have embedded video support. So if you're interested in a piece of new technology or functionality or something that you might not have used for some time, you'd simply hover over the icon for that function, and then you'll see maybe a 20, 40, 60-second video explaining exactly how that tool set is used in the environment. So there's some pretty nice design considerations that have been put into place with the way that the interface works.
Yeah, that's interesting. You talked about the direct modeling aspect in Apex. Could you also talk about other core technologies that Apex includes? For example, when we talk about generative update, how you do incremental verification, all these points, maybe you can talk a few of them and then go a little bit into detail for each.
Yeah, okay, certainly. Yeah, I have a list on the side here, which I might refer to. Yeah, we've got direct modeling. You mentioned generative update. Generative update is a concept whereby if you're to change an aspect of the model, so let's say you changed, I don't know, the position of a stiffener within a structure, or maybe the diameter of some holes or something like that, then the model updates automatically. So the geometry is linked to the mesh, is linked to the properties, is linked to the loading. So it's a very, very simple way of updating the model. And again, saving large amounts of time in terms of the build and analysis process. We've got incremental verification again. So this is a concept which allows us to look at a structure in a very, very ordered assembly, subassembly, and part definition. So imagine an aircraft, for example. You might have parts which make up a wing structure. That wing structure makes up a subassembly, and then the subassembly makes up the larger full aircraft assembly. And what we can do is we can verify the behavior of each one of those parts, or subset of those parts, within a subassembly and then an assembly before we run the full analysis of the structure. So it effectively gives us confidence in the build to be able to know that when we actually get to the final structure that we want to solve, the model's going to run first time every time, and we're not having to go back and backtrack into the assembly to find problems in areas where we hadn't seen those issues during the process.
Yeah.
Okay.
You rather talked about a bigger problem right now, but when we take a step back, like who should actually use Apex in the first place? Is it for beginners, intermediate users, maybe even experts? Who could use Apex?
Yeah, that's a big topic in itself, and I've actually presented a couple of times on the sort of demographics, if you like, of who would be looking at Apex in general terms. So you've got people like myself, so expert users of FEA technology, looking at complex simulation and complex structures, and Apex will work. It would give us the granularity in terms of the model definition and response that we would need. But equally, because of the ease of use and the flexibility in terms of the interface, people can get involved in the technology pretty much at any level. So somebody, maybe a university student who's looking at some simple project work, can pick up the tool pretty quickly, run some simulations with the embedded solver, and look at the output, in the blink of an eye, really. So it covers the full spectrum of use case, user experience, if you like, in terms of who would be who the product is targeted at.
I think that the barrier to entry is also very low, rather low, I would say. You also have a beginner course on Apex for student, more on the student level, academic level. And I've seen the classes. You kindly registered me to them. And it's rather very low barrier to entry. Like, can you maybe explain like how to get started? Like, what resources can people jump on to jump on the Apex hype train?
Yeah, okay. So I mentioned that I develop a number of online classes that people can use to get to grips with the technology. So our flagship course is called the Intro to FEA with MSC Apex. And that was released probably about 2.5 years ago, and it's obviously been updated for new functionality as the product grows. So we've had hundreds of people through that course from a professional background, blue chip companies, OEMs and tier ones into various different industries. But I took the view that because of, like you said, the low barrier of entry into the technology, I wanted to open up that learning experience to as many people as possible. So Hexagon MSC offer a free student version of Apex. The student version is fully functioned. It has a node limit in terms of the model size that you can build. I think it's 50,000 nodes that you can build. So what I've done is I've ported the professional course into an academic version, and that's been built around the academic or the student version of Apex. So theoretically, if somebody wanted to learn Apex or wanted to learn just FEA in general and have access to a very powerful contemporary FEA tool, they can pick up the student version of Apex for free, and then they can access the Intro to FEA with MSC Apex course that I mentioned for the academic users at a very low price point to get people started with the technology.
And we'll definitely link that in the description. Thanks for mentioning this. How do you see the mix between theoretical knowledge and practical knowledge? So actually not only using the tool, because we mentioned in the beginning, it's just a tool that you use. Where do you see like the balance between practical and theoretical knowledge?
Yeah, no, that's a big question. You've already mentioned the collaboration I'm doing with Dominic Madier of the FEA Academy. So we have a separate course again for a wider learning experience, if you like. But in general terms, if you do have some theoretical background in FEA, maybe through university studies, then the next step would be to look at the practical application of those techniques into a modeling and simulation environment, coupled with the ability to use the software to put those techniques into practice. So, there's many examples of people using software tools where they don't really understand what's going on in the background. But equally, there's lots of theoretical learning you can do without using the practical application. So for me personally, it's always a good balance to have some understanding of the theory and the fundamentals, but then the ability to put that into practice with real world examples. So the Intro to FEA with MSC Apex course that I mentioned, it doesn't get into some of the very in-depth academic or theoretical studies, if you like. It assumes that you do have some background in that, but then it does definitely look at the practical application and the software usage for you to be able to develop some pretty complex models and understand the simulation and the output that you would see from those models.
Because hundreds of students have already taken your classes, do you see common questions arising when taking the course? For example, some, maybe common misconceptions about FEA in general. Because when I compare FEA and CFD, I would say, maybe that's a controversial view, is that FEA is maybe the barrier to entry again is a bit easier. Like it's a bit easier to get into FEA than CFD, but there are still some common misconceptions. I don't know, maybe we should talk about mesh conversion, singularities, all these kind of things. Do you have some like maybe 5 common misconceptions that?
Blimey. Okay. Common misconceptions. I think one main aspect of the way that the teaching is done within Apex environment is, and this I've seen this myself in my early career, is that because the user interface and the functionality is much more clear in terms of what you're trying to do, it enhances the learning experience because you're using Apex as a tool to solve an engineering problem, as opposed to software courses I may have done 10, 20 years ago, where you're really looking at where do you click, where are the buttons, how do I access the functionality. So I think the again, the beauty of Apex is because it removes a lot of that heavy lifting, if you like, in the software environment. It means that people can focus on really what they need to be doing in terms of the engineering for their job or for their learning if they're more of a sort of student or coming from an academic background. I don't know if that really covered a top 5 list of misconceptions, but that is something that I'm definitely pretty passionate about, is making stuff available and easy to follow and easy to use for people to get the best from their learning experience.
Mm-hmm.
Okay.
The answer partially covered my question. Maybe I just have to reformulate it. Maybe that wasn't the best question I answered. Is maybe when you work through a specific use case or workflow, some errors that might occur. For example, I don't know, a drone arm, for example, they do some mesh conversion study on that drone arm. Maybe there's some singularities in the mesh, whatever it might be. Some things that you have personally encountered, and maybe that students can easily learn inside of your course, or whether that's in the documentation of MSC Apex, when it comes to FEM related problems, or even nonlinear mechanics.
Okay. Yeah. So again, without getting into too much depth in terms of the simulation workflow in the Apex environment, but one very powerful technology which we didn't talk about is something called analysis readiness. Mm-hmm. So if we build a model, we will see things like mesh quality, element distortion, whether we'd forgotten to put in a material or particular property into the model, whether we've got a constraint missing. So these things are all handled within the environment. So obviously, Apex can't know everything you're trying to do up front, mm-hmm. but it really helps you along the route. I mean, what one nice aspect is that if you're running a linear static analysis, or trying to run a linear static analysis, and you don't have a fully defined set of boundary conditions, then legacy software will just fail. What mm-hmm. Apex will do is it will give you the output showing any rigid body motions that you've got in the model, and then you can see really quickly there's a singularity, there's a lack of stiffness in X, Y, or Z, or whatever, and you can see that immediately in terms of the model response. So lots of things there to handhold you in terms of your understanding to give you a model which runs efficiently and effectively.
Mm-hmm. What you just mentioned, is there also some kind of, because I don't know the tool by heart, is there some kind of recommendation for the engineer or the student saying, by the way, you forgot something, I would recommend you to do X, Y, Z? Is that available?
Well, certainly in terms of a standard workflow that we'd look at. So generally speaking, that will go from geometry through to mesh, through to properties and material definition, loads of boundary conditions, and then analysis setup. So all of that kind of job setup or workflow is covered within the content, so people have a good understanding of what they need to do.
Nice. In terms of solvers, what does Apex provide people with? You talked about linear analysis, static linear analysis, non-linear analysis was probably also covered.
Yeah. So I wouldn't say it's complicated, but it's Apex can be used in a number of different ways. Okay. Mm-hmm. So in its simplest form, it can be used to build a model, solve a model internally using its own Nastran-based internal solver, and then post-process the model. Okay. And the solution sequences that are available in that particular workflow are linear static, normal modes, so normal modes dynamic analysis, if you like, linear buckling, and linear frequency response. Okay, so we can look at some structural stuff and some dynamic stuff as well. Okay, but we can also use Apex in as part of a larger workflow or larger strategy where we can export an analysis ready file and then solve in an external analysis solver, if you like. So Apex is coupled nicely with MSC Nastran, so it does have some significant nonlinear capability as well
Nice.
for lots of different things. So geometric and stability type nonlinearities, contact nonlinearities, and material plasticity type nonlinearity as well. So there's a whole range of workflows that are available. I mean, we also have sort of side Apex products, if you like. So products that can be used for atoms or multi-body dynamics integration as well. So people working in the automotive industry, looking at vehicle dynamics, can
Nice.
couple a kinematic analysis with an FEA analysis and that kind of thing. So there's a lot of ways that Apex can be, lots of different ways in which Apex can be used. I think I have a 10, 12 minute overview video, which maybe we could link to as well, so people can get a full idea of how it's used and where it's used.
Definitely. Really cool insights. What about topology or shape optimization? Is it also available instead of
Yeah,
Apex?
yeah. So there's a partner product again called Apex Generative Design,
Okay.
and that can be used to look at shape optimization. It does it in quite a novel manner in the sense that it keeps the geometry form as smooth as possible. So legacy topology optimization will look at a mesh-based solution and element removal, and that will give you a staggered sort of staircase geometry at the end of the optimization. But with Apex Generative Design, it smooths the geometry all the way through the optimization, and it has tools in there to be able to verify those final geometries with a Nastran based solver as well. So there's lots of capability in there as well.
Really cool. And I
Right.
definitely, if you send me some links, I'll put that in the description as well.
Yeah.
And
Okay.
if people want, feel free to check out Steff's course, and maybe there's some nice discount Steff can provide you with. How long have you been in the FEA industry now, like doing FEA?
Well, my background is, so I took an engineering degree and then did a doctorate, postgraduate basis, and I finished that in 2000. So with my doctorate studies, maybe 4 years of FEA, and then into 22 years since then, in terms of
Crazy.
my experience with simulation in lots of different companies and industries.
Yeah. When you look back to a career when you started with FEA, how did the tools change in general? Like from the very old, outdated, and some companies never updated their UI in the first place to now using Apex. Like, how do you see the change of FEA? And Steff, maybe where do you see the future of FEA going? Maybe if we talk about disruptive technologies such as augmented reality, artificial intelligence, maybe you have your own opinion to that.
Yeah. Okay. So I think the first tool I used in real anger was Abacus for some
Me too.
nonlinear optimization work that
Yeah.
I think we've talked about in the past. And so that was back in '96, and I remember basically trying to learn the technology on my own, which was not for the faint-hearted. It's a complex subject, and it's it's difficult on your own to learn these things. I remember having maybe a pile of Abacus manuals that was maybe 2 feet high on my desk. It was unbelievable. So that looking for examples for sort of workflows that I might be interested in was difficult and very time consuming. So obviously we've had big advances in terms of the UI and the software capability. So those things are going to continue. I don't think we're going to get to a point where, well, it's probably a long way away, where the engineering thinking is removed from the process. But things are going to get easier to use the tools to allow us to be effective in our jobs as engineers. So yeah, you mentioned disruptive technologies. There's a whole host of things, isn't there? I mean, sort of cloud-based solvers is a big thing in terms of both speed and file size. So in the early days, very, very much focused on how things were going to how long things were going to take to run, how quickly we're going to fill a disk up, and that kind of thing. So those problems are theoretically going to be going away with some of the cloud-based stuff that we're seeing. AI, well, the AI is used in many different areas already, in terms of optimization, but also optimization of a workflow as well. So I don't know, maybe the ability to go from a CAD source to a fully functioning FEA model by removing some of the user interaction is definitely an area where we're going to see big advantages and advances, I think.
Very interesting. So cool. I think you shared pictures with me via email, which was on. Let me try to recall that the McNeil Schwendler Corporation, the first 20 years, I think it was called. Like maybe give the people kind of a short overview of what the past looked like for FEA and how lucky they actually are to have a tool like Apex nowadays.
Yeah, okay. I actually got the book on my shelf just here. So a bit of background in terms of some of the commercial tools that are available today. So the main, well, one of the main tools that's in use today is MSC Nastran. So MSC Nastran was developed. The story goes, there may be a couple of holes in what I'm about to say, but basically the space race in the sort of early, mid, late 60s, all the codes were developed internally through NASA and its supplier infrastructure. So that there was a move to look at commercially available codes at that time. And there were two gentlemen, Mr. McNeil and Mr. Schwendler, who were working for NASA or one of the subsidiary companies. And they left to form their own company, the McNeil Schwendler Corporation. So that's where the MSC comes from. And they commercialized one of the very first FEA codes that sort of saw widespread adoption, certainly in the space industry, and then latterly, aerospace and automotive and what have you. But that company then grew the technology through the 70s, and originally it was, I don't remember these days myself, but it was all punch card based. So people would have to punch the cards and feed them into the computers, the supercomputers of the time. I remember a colleague of mine, an older colleague, when I was first starting out, telling me that they would design an FEA mesh on paper with all the coordinates and what have you, and the mesh layout. That would then be translated into a punch card basis, and then that deck of cards would then be stored and taken on a train to a computing center, and then those cards were then fed into the machine. The mathematical model was built, and results generated, and then maybe a few days or a week or so later, you would get a pile of results, paper-based results back, and you'd go through, and then you'd try and make sense of what you'd been looking at. So those early supercomputers, way less capability than what everybody's got on their smartphone these days. So massive change in the industry from those days now to some of the technology that we've got available to us. The ability to run some pretty hefty models on desktop machines or laptops, in seconds. And I've seen that myself. So some of the nonlinear models that we're looking at now, we can run in less than a minute, and we may have been looking at a number of hours or even overnight previously. With some of the older solution methods and model building techniques. So
yeah, really
big changes.
Definitely, really crazy to think about it. We live in luxury, so we have other tools available that are based on the cloud, or maybe you can just locally install Apex. Really, really crazy to think about it. And I actually have a blog post on my website, an introduction to FEA, where there is a video where people show how that actually works, where they have like a pen and try to go along the structure, and then it will be translated to punch cards, and then if the punch cards go to the system, it's really, really crazy. Really, really spoiled, I would call it.
In fact, one hangover from that, just to finish on that topic, is that in MSC Nastran terms, we still have text files which are submitted to the solver. So the UI takes a 3D type model, or 3D, 2D, or whatever, translate it into a text file, and that text file is then read by the solver. But the terminology in terms of the that file framework is that we still have cards within the deck. So each line is referred to as a card, and then the file itself is called a deck. So the terminology comes from those early days where some poor person was sitting on a train taking the cards to a computing center. So,
yeah, I didn't know that. Really interesting.
yeah.
If people want to jump in on the FEA train, however you want to call it, what projects should they get started with? Like a very simple project. Maybe you can give people out there kind of a guideline for FEA beginners. How should they get started? Maybe even book recommendation stuff.
Oh, well, if we're talking a book recommendation, then I think there's only one book that people need to consider these days. I think you know what I'm going to say. Yeah. So I mentioned FEA Academy, Dominic Madier. So his I can't remember the title actually, but his book on practical FEA is first class. So when I again going back to my early career, I find it really frustrating that predominantly the books that were available were mathematical theory, which is fantastic, and you need to appreciate some of those things. But there was nothing there to say this is what you need to consider when you're looking at a lightweight structure, maybe a wing. This is the type of thing you need to consider for a joint design, or this is what you need to look at in terms of tying a strategy or a workflow together to go from input to output and get a model that works. So Dominic's book is really good in terms of putting down on paper some of the practical aspects. Coupled with the theory, he does talk about some of the theoretical foundations as well, but the practical aspects that people need to follow or need to understand to be able to to get involved in FEA and use it efficiently as a tool.
Definitely. I have it actually on my book. It's called Practical Finite Element Analysis for Mechanical Engineers. Rather long title, but definitely great book. Highly recommended. Great job, Dominic, in case you're listening to the podcast.
One aspect regarding that book, so perhaps a little bit of personal information here, but I'm working at home today, but I have an office maybe 2 miles away. So occasionally I go by bicycle. Sometimes I go by car. If I'm moving Dominic's book, I do it by car because it's a big, thick, heavy book.
Yeah, that's true.
It's too heavy to carry on a bicycle, should we say?
That's true. I think it's over. Yeah, I'm just looking 645-ish pages. It's crazy. Yeah.
That's a beautiful reference book.
Definitely. Also great illustrations. MSC Apex, is it kind of a hybrid model, I would call it, that you can install it locally on your machine and also use it on the cloud, or is it only for local installation?
Yeah, at the moment it's local installation. So you'd install the software certainly for the pre and post. So the model build, the pre-processing, and the results exploration, the post-processing, you would run that locally. You can solve the FEA model locally as well if you wanted to, or you can run that in the cloud through whatever system that you've got access to, maybe a high-performance computing service, that kind of thing. So run the results and then pull them back to your laptop or your desktop machine to interrogate as needs be.
Really cool.
Okay.
Do you also feel like in the industry there's a bit of a, I don't know, should I call it pushback from engineers who are very used to their traditional R&D tools, whatever they might be using?
Yeah.
And when you introduce something new, quote unquote, such as Apex, they might be a little bit hesitant to adapt to new tools. How do you see that?
Yeah, I come up against this quite a lot. So I would say in the early years when we were pushing Apex into companies, maybe 5 years ago, it was a very difficult conversation to have. You're talking about workflows that using legacy tools might take days or even weeks. And if you start talking about being able to run or to build those models in hours or even less than that, people have skepticism about what you're saying. So the ability for me to demonstrate these approaches in the Apex environment has been pretty important for us to be able to get the message across. Equally, you've got I fully understand somebody may have access to a software tool that they've been using for some time. That you've got to consider that they've been up a learning curve already to give them the capability in that tool. Why should they then spend time looking at something else that is going to effectively do the same thing, but in a shorter time frame? So you do have to push some of the time frame and the commercial aspects across to companies in terms of this type of capability. I mean, if we're looking at an academic user base where there's no sort of hangover in terms of software usage, then it's a perfect tool to get involved with, because people can pick it up and, I say, use it as a tool without having to waste hours and hours or days and days understanding the product structure before they actually use it to solve an engineering problem.
That makes sense. So to every student out there listening, if you want to put another skill on your CV, take the course from Steff and put MSC Apex on your resume. Last maybe question before we wrap it up is a PhD necessary to do some kind of fancy FEA stuff or delve into the sometimes difficult world of FEA? Because you have done it. Would you recommend it? Would you do it again, Steff?
PhD? Well, I took a PhD 96 to 2000, so for a 4-year period. I did it because I was particularly interested in a particular aspect of simulation. It was focused on optimization, which was quite a new field. Structural optimization, quite a new field back then. I wouldn't really suggest that you need a PhD at all to get into simulation by any means. The one thing which I do think is pretty useful, and I forgive me, Jousef, I'm not sure if we spoke about this previously, but NAFEMS, the body that looks after FEA learning or sort of industry-wide learning, offer a route to simulation competency called professional simulation engineer status. And there are 3 levels. I think there's basic, intermediate, and advanced level. I hold a PSC certification at advanced level, but somebody who's getting into FEA simulation, it's a pretty good framework to look at in terms of demonstrating competency in certain areas. So there's a whole wealth of different topics, linear statics, nonlinear dynamics, composites, optimization, fatigue, you name it. I think there's maybe 30, 40, maybe even 50 different areas that people can become certified in, if you like. And following a university degree, that's probably a pretty good thing to be looking at for a young engineer who wants to develop themselves in a simulation environment. And again, a lot of it depends on the company that a young engineer might be working in. I was lucky when I finished my doctorate studies, I took a position with MSC in their support team. So really, really good way to learn the in-depths of the details of lots of different industries in terms of what lots of people are doing. So I would say PhD's not really mandatory by any means. Get yourself in a good company where you're going to be, encouraged to develop the skills that are required. And if you're not in a company like that, then there's plenty of opportunity for learning outside of that kind of job role. Again, following some of the NAFEMS stuff, maybe looking at Dominic's book, maybe looking at some of the online course. Some of the Evotech Apex stuff is ideal for this kind of thing, really. But there's lots of opportunities for people that certainly don't involve PhDs.
Really interesting. I also love that you mentioned the mix of resources. So basically, taking a course here, having the book, maybe taking another course or reading yourself, updating yourself online. Really interesting. How much would that certification actually cost from NAFEMS? Do you have any numbers?
I don't know. We maybe we could link that
Definitely
in as well. I'll make a note of that. Get the link over.
Sounds good. Really cool.
I know it cost me, I think it's £80 a year to keep it ticking over.
Really?
But I can't remember what the original cost was for me to to take it in the first place.
Cool. Yeah, we'll see, and then we'll put the link in the description for anyone who wants to check it out. Cool. Steff, any closing remarks from you and any motivating words for all the FEA enthusiasts out there?
Motivating words. Well, there's lots that can be said, really. I think, wherever you are in your career journey, simulation's a pretty exciting place to be. You can solve some pretty cool problems. You can be involved in some pretty cool types of structural development. It's definitely a rewarding career path that I've certainly had. So yeah, I definitely recommend people with an engineering background to be looking at simulation, FEA, all the different CA technologies in terms of where they might want to go with their careers.
Incredible, Steff. Thank you so much for being on my show. I'll see you in 3 days again with Dominic on my show talking about nonlinear FEA. So if everyone is interested, make sure to hit that subscribe button. I'll link to Steff's LinkedIn, his course, as well as the NAFEMS resources we mentioned in the description. And with that, thank you so much, Steff. I wish you an awesome rest of the week and hopefully see you soon.
Good stuff. Thank you, Jousef.
Take care.
Appreciate your time.